Alright, today we're going to talk about graphing tangent. So as you can see right here, here's our general equation for tangent, and as it says right here, and as you probably already noticed, that it looks really similar to sine and cosine, and it is. It's really similar. The A, the B, the H, the K, they all mean exactly the same thing for tangent. A talks about our stretching and shrinking vertically. B talks about our stretching and shrinking horizontally. Our H and our K is our movement left and right and up and down. So all those things are identical. Now, the only thing that's really different is that for tangent, our period, instead of 2 pi over b, is pi over b. Okay, and you can see right here, I have right below it, this is basically what y equals tan x would look like. Now this is completely different than sine and cosine. And you'll notice that since pi over b is our tangent, so in this case, my period would be pi over our b value right here is 1. So the period is pi. And you can, if you just kind of take a look, see how we have this shape right here, that's right between negative pi and pi over, or negative pi over 2 and pi over 2, that's 1 pi in length. And then again, that shape occurs again. And again, that's 1 pi in width, if you want to call it. Okay, and that kind of sideways S, if you will, kind of a backwards S, I guess, that repeats over and over again. Now, something that's unique to tangent that that sine and cosine doesn't have is they have these things called asymptotes. I think that's something that we have talked about before. Asymptotes. On the what an asymptote is kind of like this invisible force field. If I could draw it dashed right here. There's this asymptote in between every one of these little squiggly little things. And what asymptotes are like I said, it's kind of like an invisible force field. It's this line here where this graph, as I curve it, and it'll get really close to that asymptote, but it'll never cross over. Same thing as we go down this direction. This will get really, 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 really close, but it'll never cross over that. And the same thing with this one. As I go up, it'll get really close to this one, and it'll get really close to this one, but they'll never cross over. And what's the significance of those asymptotes? Well, those asymptotes are the locations where tangent is undefined. So for instance, like right here, pi over 2. Pi over 2 is the same thing as 90 degrees. So if I were to take my calculator and type in tan 90 degrees, you see I get domain error. And that's because that's where tangent is undefined. And all these places, 3 pi over 2, negative pi over 2, negative 3 pi over 2, all those are locations where tangent's undefined. And so this graph, like I said, is incredibly different than sine and cosine. But the nice thing is when we work on that box, using our box method, the way we go about it isn't a whole lot different. So let's try. So let's just again start with the most basic graph, y equals tan x. So I'm going to start with the box. Now we're going to do a few things different to it. Okay, so the first thing, well, let's start here. Sorry. Now, what I'm going to do is I'm actually going to split this thing up even more. So I'm going to actually split it up this way. And I'm going to split it up this way. Okay, so we got a lot of boxes in there. All right, now one of the things the first thing that's different about tangent versus sine and cosine. If you remember, sine and cosine, this line represented the y-axis and this represented the x-axis. Well, you got to imagine this right here representing the y-axis this time, and this representing the x-axis. Okay, And then what we're also going to do, if you remember when we did sine and cosine, we drew in what the sine or cosine would look like. Well, we're going to do the same thing here. Now, the way we're going to do it is this, is we're going to put 3 dots right here. And I'm going to draw the little curve. And you can kind of see how that would represent one of these curves. Okay, you can kind of see how this represents one of these. Okay, now every time we do this, okay, at the ends right here, these are my asymptotes every single time. Okay? So before I do anything, before I think about A, B, H, K, any of that stuff, I'm going to do that. Now, let's go through and do basically everything else we've done in the past. This right here, this value right here is still going to be my K. So in this case, it'd be 0. Now, because this essentially is my origin versus this, I'm going to put my H value here. So in that case, it's 0. Okay, next thing, let's talk about our A value. Our A value in this case is 1. So our amplitude is 1. So, just like before, I'm going to, now I'm not going to go all the way to here, I'm just going to go to here. So this would be 1, and this would be negative 1. And then my period is 2 pi over 1, 2 pi over b, or pardon me, not 2 pi, pi over b. So my period is pi. And so that means the length, all right, from here to here has to be pi. Okay, well, if this is 0, that means I have to have half of it this over here, and the other half over there. Okay, so far so good, hopefully. So then what's halfway between 0 and pi over 2? Well, it's pi over 4. Halfway between these is negative pi over 4. Okay, and I've done the box. So, how do I transfer that over? Well, we're going to do it just like we've done any other one before. So I'm going to just basically draw an x and y axis here on my chart, just so we're all kind of together. Now, just like before, we're going to use the same scaling. So I'm going to use 12 equaling pi and 12 equaling 3. Now, so what that means, if I were to measure this all out, if this is 0, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here is pi. So halfway, 3, 4, 5, 6. That's my pi over 2. Now, halfway in between there, there's my pi over 4. And let's go the other way. So let's see. 1, 2, 3, that would be my negative pi over 4. 1, 2, 3, that'd be my negative pi over 2. 1, 2, 3, that'd be my negative pi. And so now, in terms of my up and down, if 12 is going to go to 3, that means 1, 2, 3, 4, that'd be 1. And then I could keep going, 5, 6, 7, 8, that would be 2, keep going that way. Same thing here, 1, 2, 3, 4. Okay, so again, this 12 equaling 3 going up and down essentially is telling you that to get up to 1, you have to go 4 marks. 1, 2, 3, 4. You can do that, obviously, 3 times, you get to 12. So let's fill in stuff we know. Negative pi over 4, negative pi. 0, 0, pi over 4, 1. I know there's an asymptote at pi over 2. I know there's an asymptote at negative pi over 2. And I'm going to draw my graph. Okay. Now that's not it though. Remember, you need 2 periods. So I am just going to go to the right, and this pattern will continue. And so if it helps, go ahead and fill out the box and just keep extending it, but I'm not going to. I'm just going to fill in here. This is going to be 3 pi over 4 pi. This will obviously be 5 pi over 4. Okay. And then If we keep going, again, this is 2 pi, 3 pi, 4 pi, 5 pi, 6 pi over 4. Well, what is 6 pi over 4? Well, that's 3 pi over 2. Okay, and so that's an asymptote because the period is pi, so that's the distance. Here, there'll be a dot. At 3 pi over 4 will be a dot. At 5 pi over 4 will be a dot. And I'm going to continue up, just like that. And there you go. There's my 2 periods. Okay, hopefully that made sense. We are going to continue on. We're going to do another one. Let's try this next one here. Graphing this one. Now you notice that this one looks a little different. Notice here how I have this 2 on the inside right there. Well, that's kind of a sneaky way to write this. And so what I'm going to do here to start is I'm going to factor out a 2. If I do that, I get x minus, now if I take 2 out of pi, what do I get? I get pi over 2. So those mean the same thing. And so I'm going to go through and let's fill out the box. So here comes the box. Draw this. I'm going to split it up. Okay. So, what are things I know? Let's see here. Let's talk about the k value. Well, k value is 0, so that's 0. Amplitude, well, this is 1, so this is still up 1 and down 1. Let's talk about my h value. Well, that's right here, so this is at pi over 2 right there. And that's your h value. Now let's talk about period. Period is 2 pi, no, did that again. Pi over 2, pi over b. Okay? So that means this whole thing has to be pi over 2. So that means if I split that in half, that's pi over 4. So pi over 2 plus pi over 4 is 3 pi over 4. And if I take pi over 4 away, I get pi over 4 here. Okay? So what's halfway? Well, if you remember before, if I'm taking pi over 4 to go here, halfway would be taking pi over 8 to go here. Alright, so let's see here. What would that be? Well, that would make this 3 pi over 8. Add an 8, 4 pi over 8, which is that. 5 pi over 8. And this would be 6 pi over 8, which is 3 pi over 4. Okay. Asymptotes are here at the end. You don't actually have to draw those asymptotes in, but I like to. Put my dots. And there you go. There's my graph. Okay. So I'm going to run out of time here in just a minute, so I'm going to just hit pause, and I need you to watch part 2 of this to see how this all turns out. Okay? Thank you.